Good afternoon, dear students. Now we continue the next part of the synthetic dyes. That is the part 2. We have read in the part 1 the introduction of the dyes, the difference between the dyes and the pigments, the history of the dyes, the requirement of the dye, and we have seen the classification. The one of the classification we have seen, that is on the basis of the source of the materials, that is the natural and the synthetic dyes. Now in this part we continue the classification on the basis of other factors. So in this lecture, we are going to understand the another classification of the synthetic dyes, that is on the basis of the chemical composition, meaning the group which is responsible for the color in the dyes. On the basis of that, we can classify the dyes into the following types: the nitroso dyes, azo dyes, triphenylmethane dyes, anthraquinone dyes, indigo dyes. So that is one of the important classification of the synthetic dyes. What is the learning outcome of this lecture? The students will able to understand about this important type of classification of synthetic dyes on the basis of the chemical composition, meaning the group which is responsible for the color in the synthetic dyes, and he will able to differentiate between each kind of the dye on the basis of the groups like azo dyes, nitroso dyes, triphenyl methane dyes, anthraquinone dyes, and the indigo dyes. So the main differentiation is between the groups present in these dyes. So we can go through it. So we see the classification on the basis of the chemical composition. It's the second factor on which we are understanding the synthetic dyes, and we have read the first classification on the basis of the source of the materials. That was the simple classification. Now we can also say this classification is on the basis of the chromophore present in the dyes, because I have said that the groups which is responsible for the color in the dyes, on the basis of that we can say the classification depends, and it can be said as the chemical composition, and the groups which is responsible for the color is called chromophores, because the various theories which are put forward to understand the dye coloring, and he put forward the term given to the groups present in the dyes which is responsible for the color, called chromophores. So we can also say that this classification is also on the basis of chromophore present. If anybody asks, can you classify the synthetic dyes on the basis of the chromophores? So that comes also in this classification. You can easily tell them that yes, the nitroso dyes, azo dyes, triphenyl methane dyes, anthraquinone dyes, indigo dyes. These are the dyes on the basis of the chromophore present, and we can easily differentiate between all these dyes on the basis of the chromophores. So let's see, the one of the type of the dye on the basis of this classification is the azo dye, and it is the large class of the synthetic organic dyes that contain the azo group. The chemical composition group is the azo group, that is N double bond N, as a primary chromophore which is responsible for the color. More than half of the commercial dyes belong to this class of the dye. So we can say it's an important classification of the azo dye as having the group N double bond N, and these dyes are highly colored, give the bright color in the application, and prepared by diazotizing an aromatic amine and coupling with the suitable aromatic compound. So this is we can say an important class of the dyes, which is half of the commercially used in the application. So here you can see the example of the azo dye. It is called the para red, having these two naphthenic group with having the hydroxyl group here, and is having N double bond N. So, and having this nitro group also. This is N double bond N is the primary chromophore present here, and having this also the nitro group is there. So it is a para red dye. Also the methyl orange, which is mainly used in the labs in the acid base titration, Congo red, it is also used in the food and the textile manufacturing. So azo dyes application, if we see in the food as well as in the clothes and the fabric manufacturing, it is used. So these are the examples of the azo dyes: para red, methyl orange, Congo red. Even EBT is also one of the example of the EBT here. I can write here that you can give the example of this azo dye. It is also EBT. EBT is also one of the example of this azo dye, including the methyl orange, Congo red, para red. So EBT full form is aerochrome black tea. So it is also having the azo group as a primary chromophore, and it is initially the black in color. EBT is black in color. So the next category in this classification is triaryl methane dyes, and these are the synthetic dyes which contain mainly the backbone of triphenyl methane backbone, and it is the chromophore. This is the main structure present in the dye, this group, triphenyl methane group, which is having in this category. And these compounds are intensely colored, having the bright color by this group, and are produced industrial level. So in a large scale, they are produced such kind of the dyes. For example, the famous dye in this category is the malachite green. You can able to see here the main chromophore present here. This is group. One carbon atom is attached to the three aromatic rings. Understood? And these rings, three aromatic rings, is only the phenyl group. Understood? So the one carbon atom is attached to the three aromatic ring, and this is the main chromophore present here, responsible for the color green. And this nitrogen with the methyl group here, alkyl group is there, two methyl groups attached to the nitrogen here also, and with the next aromatic ring is also there attached. Nitrogen with the alkyl group give us these are the oxochromes actually, which enhance the color enhancing group. The oxochromes are the group which is responsible for the color enhancing. So you can able to see the primary chromophore is this triphenyl methane, and this nitrogen alkyl group is the oxochrome, which gives its intense color. So we can say the central atom in this category is bonded to the three aromatic ring, as we have seen in the structure of the malachite green. One is of the cunoid form. It can be or it cannot be. Oxochromes here, the NH2, NR2. As NR2, we have seen the 2-methyl group with the nitrogen, and 2-methyl group can be displaced by hydrogen, means NH2 can be there, NR2 can be there, and it can be OH. All these are the oxochromes, color enhancing groups in the dyes. So malachite green come in this category, which is used as a direct dye. We can use directly in the application for coloring the wool and the silk. Understood? And the next important example of this category is the phenolphthalein, which is mostly used in the acid base indicator. So phenolphthalein is also the dye which comes in this category of triaryl methane dyes. So phenolphthalein is used as an indicator purpose. The third category of this class is anthraquinone dyes. It is also an important class to understand on the basis of this classification. Any of the group of the organic dyes having the molecular structure based on the group anthraquinone. Anthraquinone means having the three, we have the benzene, with the middle one having this quinoid form, double bond O, double bond O. This is the anthraquinone structure. So the three, we can have the benzene ring, the middle one is having the quinoid structure, that is called the anthraquinone. So any of the dyes, if it is having these three benzene ring with the middle double bond O quinoid form, this is come in the category, and this is only responsible for the color in these dyes. So you can easily understand the anthraquinone dyes. What are these dyes? If you find this structure in any kind of the compound, it acts as the dye, and the important example in this category is alizarin. It is the anthraquinone dyes, and it is used for the coloring the red color as a textile dye. Understood? So that is, we can able to understand anthraquinone dyes. So the next class in this classification is the indigo dyes. It is an organic compound with the distinctive blue color. This is also the class of the dye we have seen in the natural dye category, because it is a natural dye extracted from the plant. But today, nearly all the indigo dye is produced synthetically. For the large scale, if we want to use these dyes, so they are prepared synthetically in the lab. So what type of the chromophore present in this natural dye, or if we are preparing as a synthetic form? It contains the carbonyl group as a chromophore. So that is main here in the naphthenic group. Here C double bond O. This is having the carbonyl group here also, here also. So that we can easily understand. If the organic compound is having this chromophore as a primary chromophore, it is responsible for the color. That is the indication of identifying the indigo dyes. It is having the distinctive blue color because of this carbonyl group. Understood? So anybody can ask you the indigo dyes, why it is having a deep blue color or the distinctive blue color. You can easily give up the answer because of this presence of the carbonyl chromophore. It is having a deep blue color. So you can easily give up the presence of the group which is responsible for the color in the dyes. So indigo dyes can easily differentiate by the chemical composition or the chromophore by the other dyes. The famous application of the indigo dye is that it is used for the cotton yarn, which is mainly used for the production of the denim cloth for the blue jeans. The blue jeans, you all wear it. It is dyed by this dye, that is indigo dye. So it's an important application of this dye. A small amount of this dye is also used for dyeing the animal products like wool and the silk. But the major part of this application is used for the production of the denim cloth, providing the intense blue color for the jeans. So this is all about the classification based on the chromophore or the chemical composition in the dyes, and we can easily understand okay, which type of the group and the chromophore responsible for the color. We can differentiate in the azo dyes, triphenylmethane dyes, anthraquinone dyes, indigo dyes with the applications. In the next lecture, we are going to see the another factor of the classification. Thank you and take care.